Hi everyone, welcome to Online Study for You. My name is Ankan, and in this video, I'm going to cover the solutions of the coding questions from TCS NQT first shift. First shift means this is the first shift of 3rd October 2024. Okay, so we have had two questions, and in my opinion, they were pretty easy questions asked. They were like compared to the questions I covered, they were like very easy questions. So the first question, let's start with the first question, right? So this is the first question you can see on your screen. So you need to take this as your input. You need to take this particular thing as your input. Okay, and every day so this is the thing which you will get from your input, right? So this is the thing which you need to take um, as your input. So 25, 26, 23, 15, 14, 30, and 44. This is actually the exercise duration which you need to take as your input. So this is in this is given in minutes. So this is 25 minutes, 26 minutes, 23 minutes, 15 minutes, and so on. So you just need to find out the total minutes of the exercise. So what you do is you simply add all of them and you get 185. And you also need to find out the average. You also need to find out the average. So you simply add all of them, and then what you do is you simply divide it by the number of days. So number of days is 7. You're going to divide this 185 by the number of days, which is 7. So 185 by 7, it should give you 26.4, right? So this should actually give you 26.4. So this was like literally so easy, because this was like you just put everything up in an array, you find out the average, you can add all of them, you can just find out the average. So this one is really simple. I'm going to code it out in C++. Java solution is also very straightforward. So yeah, let's come up to my compiler, and all I need to do is I'm going to code this in C++. So I'll just going to do hash include bit/stdc++.h. This is the thing which we always include. And actually, I can even just replace it and start coding like this. This would be even better. So I just move this up, and I can close this add up, and yeah. Okay, so let's start to code this one up. So this is just, I'm just taking out my standard. And here, all I need to do is, okay, what do I need to do it? I can keep an array if I want to for it. But the way this input will work, it has to be inside a loop. And I have 7 inputs here, like for this particular example. I'll simply run a loop for int I equal to 0, I less than 7, I plus plus. And inside of it, I will just print out whatever it is printed over there. So it is day exercise duration. Okay, so day, give a space, print out I plus 1, because I is 0. So and I need 1 to 7 here. Okay, so it will be I plus 1. And I need to print here exercise duration. And after this, what I need to do is I actually need to take my input. Okay, so I just close my line here. And after this, what I can do is I can simply take my input. Okay. So for taking the input, one thing I can do is I can maybe name a variable here called as int duration, right, which is in minutes essentially. Int duration, I can just name a variable like this, and here I can just take my duration. Okay, and as I am taking my duration, what I can do is I can essentially add it up in my in a variable called sum. I can simply start adding up my duration. Whatever I'm getting, I'm simply starting to add it up. Before doing this, make sure you assign sum to 0, because when there isn't any duration, sum should be 0. Now, as soon as you're getting the durations, you're starting to add up one by one. So yeah, so I have the sum here with me, and now I just need to calculate my average. So once the sum is calculated here, and I guess the average is in fractions here, you see the average is in fractions here. So you can just simply take a double, average equal to, all you need to do is sum divided by the number of times the loop is, which is in this case, it's just 7. So you can just put it to 7. Okay, sum divided by 7. Okay, so double will be average, and you can print it out like this. See out total minutes. Okay, this might not be same, but you get it. For now, I'm printing it like this. So total number of minutes will be my sum. And the next line, I can also print what was 92 average minutes per day. Average minutes per day, something like this. Average minutes per day will be average. So this was as simple what was there in the question. That was all we needed to do. Now, one thing you make sure this might not work because you need to typecast sum into average. So for C++, I can do something like static cast as well. It works. But in Java, you can simply typecast this in double. Okay, so that is one small thing. You can just typecast this in double. But okay, let me run this code. Okay, so let's make this a bit beautiful. Let me stop the execution. D1 exercise. Yeah, let me give it a space here. Okay, and let me run again. Okay, now this looks really good on my screen. Okay, day one exercise duration. So let's start giving these values: 25, 26, 23. First we have 25, then we have 26, then we have 23. Then we have 15, 14, 38, 15, 14, 38, and we have 44 as well. The total minutes is coming out to be 185, as you can see. Just add all of them, and the next is the average, which is just divided by 7. It's coming to 26.4. Okay, so that is our answer. Okay, so that was our solution. Again, the time complexity of this is O of n, because I'm simply using a single loop. Okay, so time complexity is O, and that was all your first question. Now, coming to the next question, this was also really easy, but I'm not sure how much of this is true. You tell me one thing. So I was given two ranges here, right? M and N. So let's consider here this range which was given to us was like it was within the given range, and let's denote this given range by M and N. Okay, which is M is the starting, N is the ending. So 0 and 20. Now, was this given in the question that 0 less than equal to M comma N less than equal to 1000? Tell me yes or no. Because if this was given in the question that M and N has to be within 1000, or if M or N has to be in 1000, then this actually can be done in O of N time complexity. So this can actually even be optimized from O of N squared to O of N if this time constraint is true. Okay. Now, what I need to do is I need to find out the total number of palindromes. I'm given two ranges here. Okay, I'm given a starting range, ending range. I just need to find out the number of palindromes in this range, 0 to 20. Okay, number of palindromes. So the easy way of doing this is the easiest way of doing this is you just take you just take a function which will check if my number is palindrome or not. Okay, so this will take a number, and you already know how to make your number a palindrome. Okay, you already know that. How do you check if a number is palindrome? If you reverse the number, and if the reverse number is same as your original number, if reverse number is equal to my original number, then that is a palindrome. Great. So you just get the digit here. You do n equal to n by 10. So now what I have done is I have reversed my number. I haven't essentially reversed my number. I've n equal to n by 2. Now, before n equal to n by 2, what I can do is I can actually store a number, store a variable reversed, and what I need to do is reversed equal to reversed. Reversed. Let me type it properly. Reversed equal to reversed. And how do you reverse it? You multiply it by 10, and then you add this digit here. Right. And reversed, you can take something like this. So you come here. Okay. So first of all, this has to be inside my loop. So while n is greater than 0, this will occur. So this all of it has to be inside my loop. And okay, n is given to us, but what is reverse? So reverse, I can maybe initialize it as 0. Okay, I can reverse initialize by 0. Now, all I need to return is true or false. I can simply do return reversed equal to n. If reverse is equal to n, I can do it. But one thing you can see, n is getting destroyed here. N is getting destroyed. So I will have to store my n in a number called original to preserve my original state of n. And here I'll simply do reversed equal to original. Okay, I hope you know how to find out if a number is palindrome or not. All right. Because the way what we, if you still don't know, then the way what we are doing is very simple. Let's say I have a number 567. All I'm doing is what will digit store number modulo 10, which is 7. Okay, then what I'm doing, reverse equal to reverse into 10. Okay, so 0 plus digit. So first I'm getting 7 here. Okay, then n equal to n by 10. So now my new number is 56. Then I'm again doing 10% 10, which is 6. Then I'm doing 7 into 10 plus 6. I'm getting 76. Similarly, I'll get 5. Then I will do 76 into, let me write this a bit properly, 76 multiplied by 10 plus 5. So this will give me 765, which is the reverse of this particular number. Right. So this is how palindromes work. I hope everybody knows how palindromes work. Okay. And here, okay, you have already written the function, how to check if it is a palindrome or not. Now you simply take these two numbers. Okay. Simply write enter the range of m and n. Okay. That was what we were taking. So yeah, so you just enter here m and n. Don't forget to initialize m and n. I mean to declare m and n. And once you do that, all you need to do is you just need to run a loop for int I equal to m, I less than equal to n, I plus plus. If any of my I is a palindrome, okay, if any of my I, which is if any of my numbers from m to n is a palindrome, then you do count plus plus, which means I'm counting my number of palindromes. Okay, don't make sure to write a count equal to 0 here. Okay, and what I have to return here, I need to return, actually, okay, I'm returning 0. Okay, I have always return 0 here. This is a main function. I will print out the number of palindromes. Okay, so see out number of palindromes will be equal to count. Okay, so I hope all of you understood what I did here. Okay, so let's say it's given to us 0 to 20. I will check if 1 is, so what I'm going to check, if 2, like if 1 is a palindrome. Okay, then I'm going to check if 2 is a palindrome. I'm going to, if 1 check, if 3 is a palindrome, if 4 is a palindrome, if 5 is a palindrome, all the way up to is 20 a palindrome. One by one I'm going to check, and if it is a palindrome, I'm going to increase my count here. Okay, I'm going to increase my count here. Okay, so that is exactly how it will work. Very, very simple. The most simple approach which comes to your mind. And time complexity of this is O of n square. Okay, now let me run this code and see if we have any syntax errors. We'll just need to solve it. We don't have any syntax errors, so let's just stop this code and let's make this a bit more beautiful and run my code again. Okay, so let's say my m is 0 and my n is 998. Okay, okay, let's make it 1 and let's make it 998. How many palindromes are there? Number of palindromes is 107. Okay, number of palindromes is 107 between 1 and 998. Okay, and this works. Time complexity of is O of n square. Okay, I hope you have got this, right? Now we have a catch here. You tell me, because I haven't seen the paper by myself. All of this is heard from students. So you tell me one thing in the chat box. Is this true? Is this given? Was this given in the question? Then that the starting and ending range has to be between 0 to 1000. Was this given in the question? Was this given in the question? Yes or no? because I haven't seen the paper myself. But if this is true, because I've heard from a lot of students that the range was 0 to 1000. So this essentially means only 1 digit, 2 digit, and 3 digit numbers need to be checked. If that is a palindrome. Only 1 digit, 2 digit, and 3 numbers need to be checked because the range is 0 to 1000. And I know that 1000 is not a palindrome. So I won't check that. So only 1 digit, which is 0 to 9, 10 to 99. Okay, so all I need to do here is, which is like 0 to 9 are the single digit numbers. 10 to 99 are the double digit numbers, and 100 to 999 are the triple digit numbers. So basically, I have only 1 digit, 2 digit, and 3 digit numbers to compare because I know 1000 is not a palindrome. If this is true, this question can be optimized to linear time complexity. Optimize how? Very, very easy. You know that 0 to 9 is always a palindrome because it's a single digit number, right? And single digit is always a palindrome. Single digit numbers is always a palindrome. Okay. Now for 10 to 999, I just need to check if first and last digit are same or not. For 100 to 999, for 100 to 999, I also need to check if first and last digit are same or not. Because let's take a 3-digit number. Now let's take 100. Okay, let's take 979. Okay, so the only way this is a this is a palindrome is to check if the first digit and last digit is the same or not, because the only digit in the middle does not matter. Why? Because if you take one more example, 989. Again, the only thing I need to check here essentially is this digit is same as this digit or not, because the middle digit that does not matter for a 3-digit number to be a palindrome. So for 2 digits also I need to do this, for 3 digit also I need to do this. And if you need to do all of this, then you can simply do it in O of n, time complexity. I mean, like the total time complexity can be O of n because this thing can be done in O of 1. Okay, how to do this is also very easy. So you just so like considering up to 3-digit numbers. Okay, considering up to 3-digit numbers, you can actually do it in O of 1, especially this palindrome check. How? That's also very, very easy. So what you do is you just check if first you check if it is the like 1 digit or not. If it is 1 digit, that means n has to be greater than equal to 0. And then n has to be less than equal to 9. Cool. In this case, you already know this is always a palindrome. Done. If n is more than equal to 100, or I should say more than equal to 10, and then n is less than equal to 99, which is 2 digit. Return. Okay, but I need to check if the first digit is same as last digit or not. How do I get the first digit and how do I get the last digit? In a 2-digit number, let's say 99. How do I get my first digit? How do I get my last digit? So the way you get this is 999 for example, let's say 77, let's say whatever it is. So the last digit can be done by n percentage of 10. and the first digit can be like you can get the first digit by n by 10, and that is all we needed to do here if this time constraint given is true. So all I need to do here is n% 10, like n% 10 equal to n by 10. If this is true, then we are done. Same thing if it is for the triple digit numbers, which is from 100 to 999, which is the 3-digit numbers here, then you know that what you need to do is simply n. Okay, for 3 digit numbers, how do you get this? So this, okay, last digit can be got by n per percentage of 10. First digit need to be got by n by 100. First digit need to be got by n by 100. So it has to be n% 10 equal to n by 100. Okay. And yeah, that is it, I guess. Okay. Other than that, we also have 1000. So in that case, we will return false because this is for a case of 1000. If it is neither 1 digit nor 2 digit or 3 digit, neither of 1 or 2 or 3 digits, then the only other possibility is it is 1000. Okay. Now, you remember it was between 1 and 998, we had 107 palindromes when we run it the last time. Let's run this again. Okay, first of all, we'll check if we don't have any errors. 998, how many palindromes? We had 107. We have 107 again. So this also works. And the great thing is that this has been optimized to O of n. This has been optimized from O of n square to O of n. Done. You just need to do this. In case, again, I'm saying if you're considering up to 3 digit numbers, which is 0 less than equal to m comma n, like m comma n has to be less than equal to 1000. If this is true, then this code is completely fine. And this is just O of n. Okay, so many of your test cases were not passing, as I heard, with O of n square solution. I guess some were passing for some reason, but yeah, this is, you need to do exactly like this if this time constraint was given in the question. Okay. All right, so that was it. Both of the both of the solutions, if you look at it that way, both of the solutions had linear time complexity. Both of my solutions had linear time complexity, and they were easy, in my opinion. All right, so that was the review of the coding questions of TCS NQT first shift. All right. If you have any questions, please write it down in the YouTube comments, and I will answer them for you. Thank you everyone for attending. I'm Ankan, and I hope to meet you in the next video.